We're gonna wait a little bit to see if anybody join us. Oh, we're gonna wait a few more minutes and Vivian gonna start. Okay, we're gonna start right now. Now, Vivian, can you share your screen? Yes. Everybody seeing the screen for the robot? Anybody here? Can anybody hear? Okay, so it's good to go. Okay, Vivian, you can start talking about your robot component. Yeah, today's topic is about the robot design. Maybe I'm going to start with the robot component and the robot design, and then Natalie going to go with the attachment component. Okay.
This is robot components.
Loud.
These are robot components. I'm going to start off with sensors. The built-in gyro sensor can register movements and tilt and can be used in gyro turns and gyro straight. The color sensor can detect colors like black, red, blue, and other colors. The distance sensor can detect how far things are. And the force sensor can detect if it is being pressed and the amount of force being applied. Motors. There are two types of motors, a large motor and the medium motors. The large motors are mainly for driving wheels or lifting heavy objects. The medium motors are mainly used for controlling attachments. And there are three types of wheels, a large wheel, a small wheel, and ball wheels. Though large wheels are good for covering large distances, but not the best at precise movement, they provide faster. They are usually used for faster movement, and the small wheels are often used when you're not really wanting to go as fast, and they're better used for attachments. And the ball wheels are good for turning, but they're they don't really move in a straight line.
That's it.
And that's it.
That's what I'm gonna go with the next one. Is we're going to stop share this one. We'll just share the other one. Let's share. Okay. I'm just gonna talk about the robot build. Return to a component. What is that component?
So this part,
Loud.
this part is the light matrix, and this part is the sensor. You put the sensor into the light matrix, and then you flip it around. So the white part is facing up. And then so there should be the back part, the front part, and both wheels.
你叫怎么连接？
And so basically these clips show where to connect it. And so you can see that B goes to, like, the blue clip goes to port B, the red clip goes to port F, and the green clip goes to port D. Then the magenta clip goes to port A, and this clip, I don't know what color it is, but this clip goes to port C, and this clip goes to port E. And then you connect this wheel part to the front part, and like the other wheel side to the other part, to the other side of the piece. And then you could attach this part to the main part. And these axles go where it's pointed to. And that's it.
Okay.
And this is basically to put attachments on to like provide like a framework for them. You put this on, and these two red clips, when the attachment is over here, then you can push in these red clips to secure them. And you put these two axles in here, and then you try to hide all the cords. And
What type of sensor are you using for this one?
we are using the gyro sensor and 2 color sensors.
How many motor do you have?
4.
What about ultrasonic sensor?
Don't
color sensor?
I don't think that's a thing in here.
Not for this robot design. Did you use what other sensor? That's all you.
That's it. Gyro
that's-
sensor and color
Color
sensor.
sensor. Can you go back to the very beginning and see what type of sensor are you using? So it's all in there. That's the very beginning and show what type of sensor are you using. Yeah, that's all the sensor you're
This
using.
is the gyro sensor
What is your color sensor?
down here.
So what is your
See?
motor?
The motors are like on each piece. So the big motors are the large motors are used for the wheels, and the medium motors are used for the attachments.
You only have 4 motors and then 2 wheel. How many wheel do you have?
2.
2 wheel?
4 technically if you're
4.
counting the ball wheels.
Okay, so how many big wheel? How many ball wheel?
2 big wheels and 2 ball wheels.
Okay, what is it?
So the big wheels are over here and the ball wheels are down here.
Okay, what is your color sensor?
The color sensor is kind of hidden. It's down here.
Okay, it's on the ball. So what's the on the back side? This is the front. So what's on the back?
The back side is just another place to add attachments.
So what do you have on the back side?
Another motor.
Oh, that's the motor?
Yes.
Okay. So for this design, you have 2 motor front and the back, and then 2 color sensor in the front, and then one gyro sensor. Nothing else was used.
And 2 large motors on for the wheels.
Only for the wheels.
Yeah.
Okay. So are you able to show us the other Lego design? Then go back to the home. Let's see where the home is. But that's the assembly here. That's the ones the driving base part.
Those are just the parts that you
Okay. That's what we already talked about. Any other
You don't use
design base drives? And maybe go back to the parts design. Okay, that's what you already went through, right? Okay. Maybe Natalie? Any other robot? Anybody would like to take a look? This is the robot design we built up like last Saturday or Sunday, last weekend. This is the one we built. We just talk about what we used. We actually used there's one gyro sensor and then two color sensor and then big wheel and two ball wheel at front, and then front and back motor. And we can try some other robot design, which Vivian and Natalie already built another robot. Maybe next time you can test drive that one and then can discuss about what the other robot design you would like to have. Like see if you would like to add other sensor or you want to add other motors, other attachment. So that's all the items you can discover during the season. And Natalie, are you able to let me stop sharing here? I'll let Natalie to share her part.
Okay. Today I'll be sharing robot attachments. Robot attachments are tools we build and connect to our robots. They help us interact with mission models like pushing objects, lifting levers, or dropping objects. Attachments are made for specific missions and can increase a team's score. Passive attachments don't have motors. They're powered only by the movement of the robot. They are simple, lightweight, and reliable. For example, we can use a scoop that pushes a model as the robot drives forward. This is a video explaining passive attachments.
FLL teams can have a maximum limit of 4 motors. Whether that's 4 large motors, 4 medium motors, or a mix of both, the grand total has to equal 4. There are 2 main ways teams deal with this limit. The first is to build attachments that can do multiple missions, but this usually requires a lot of coordination. The second is to build many attachments where some don't need a motor. These non-motorized attachments are called passive attachments, and they are great because the more missions teams can go for per run, the higher their potential points are. They are connected to the robot the same way as any attachment, and they complete missions while only using the robot's general driving motion. With that being said, here are 3 types of passive attachments. The first are slopes. There's not really a formal name for these, but they are any angled pieces used to lift up or press down mission models. For example, in the recent crane mission, teams had to lift a lever to release a blue unit and press the right lever to rotate the crane. As the robot drives forward with a slope, the lever will slowly be forced upwards due to the angle of the Lego piece. And of course, if the lever had to be pressed down instead, the angle of the piece would just be inverted. The second type of passive attachments are dumpers. Dumpers are mechanisms that will release an object after it has come into contact with a wall or a mission. For example, in the City Shapers mission designed for wildlife, teams would receive 10 points for placing the bat onto the tree branch. One possible solution would be to create a dumper that would release the bat after it has come into contact with the tree. The last type are one-way doors, which consists of a box and a flap that can only open one way. One-way doors are a great replacement for mechanical arms, and they are extremely effective at grabbing loops, which are very common in FLL, as well as pretty much any other object. The only thing you have to remember when building one-way doors is that the flap has to be proportional to the length of the box. If the flap is too long or the box too short, objects won't be able to enter. FLL teams can have a maximum.
Active attachments use motors that are controlled by our programming. These are great for complex missions like lifting or spinning. For example, you can use a motor-powered claw that grabs the model and then lifts it on a platform. They're more powerful but also more complex. This is another video explaining both active attachments and passive attachments.
Hey everybody, what's going on? It's Mr. Hino with Mr. Hino's LEGO Robotics. Today's video, I want to talk about attachments for your first LEGO League robot missions. The attachments can either be passive or active. So today I want to just go over the difference between the two and just show you some examples of that. So if you want to see all of that, stay with me.
Hino, LEGO Robotics.
Oh yeah. Okay guys, so it's pretty easy. Active attachments would be attachments on your robot that actually get moved by a motor, medium motor, large motor. And passive are going to be attachments where it's not motor activated. So I want to give you a better picture of that by taking you to the Cargo Connect table and also bringing back some favorites from last year's City Shaper. So if you want to see that, let's go to the table. Okay, so sorry non-EV3 folks, but I have this turquoise picture frame from Spike Prime. There's the gray container. Hey, there is the curved panel from EV3. I got a picture frame in the back here just to help the robot push this. And then I have these large nails just on the sides that I'm going to insert right into here, like that. So it just helps keep this from going to the left and right. So let's go ahead and check this out. Again, the plan is going to be to have this curved panel lift the yellow bar up, and that would put this gray container right into the circle. Okay, so the switch engine's flipped and the gray container is in the circle. So 20, 20, that's 40 right there. Nicely done. So what I really like about this, and I loved the curved panels. These curved panels can do so much with the first LEGO League missions. So last year in City Shaper, this was able to do the traffic jam. Okay, so now let's go ahead and take a look at an active attachment that I modified to make it a little easier. It's going to be the home delivery. Okay guys, so when you're doing missions like the home delivery, I know it's hard to drop off something with this medium motor here because we can, drop this down, but friction sometimes will get this thing hung up. So what I did is I just put an axle through these picture frames here with these rollers. And so what that should allow this package to do is roll off of here instead of having to hope it, just drags off. So this mission here, we're just going to take this over there to the porch and hopefully get the 30 points. Let's check that out. See, that just rolls off there like that. So you're hoping that with this front part right here, that's what can help your package or whatever you might deliver in a first LEGO League mission to just come off of it a lot easier than if it's just sliding on top of plastic and plastic. Hopefully the roller helps. That's how the pyramids were made, right? Okay guys, so there you have it. Active, passive attachments. No, I'm not here to endorse one as better than the other. I would just encourage you to explore both. And as a team, agree whether you go with one, you go with the other, you try a little bit of both. But they're really cool to explore because you're able to go, hey, you know what? Not everything that we do has to be activated by motors.
The next attachments are modular attachments. They're designed to be swapped quickly between missions. We can snap them on and off easily. This can help us save time during matches. You can use axles or connectors to attach them securely.
If you're struggling with spending too much time in base switching out attachments even though they're already modular, then a great solution is to have attachments that simply slip over a build plate and use gravity to hold them in place. The first step is to build a flat mount or mounting plate where all your attachments will connect to the same way. The most important thing about a slip-on attachment is that your connection point has to face upwards, so you simply have to drop your attachments onto your robot. You can either have your attachments wrap around the frame of the robot, slide into slots within the robot, or simply sit on top of the mount. This doesn't necessarily mean that your media motors have to be in a vertical position, as long as they can still provide power into a flat mount facing upwards. The next step is to stick to a consistent frame in which all your attachments will build off of. In other words, all your attachments will use the same frame. This means that they will all connect to your robot the same way, and it will also ensure that you don't have to waste time thinking about how or where an attachment is supposed to be mounted on your robot. The last step is to add anything that further secures the attachment to the robot's mount. If your attachment slips into slots within the robot, then you don't have to worry about this too much. The most popular way to make sure that your attachments fit tightly is to add axle pins that face upwards towards open pinholes within the frame of your attachments. This way, the attachment will not shake side to side, but it can be easily removed due to the fact that axles don't add more resistance. This is also why I would not recommend using pins, because it would make your attachments much more difficult to remove. Finally, if you're using a gear system to power your attachments, I would recommend leaving a stud of room on both the axles on the robot and on your attachments, so that they can fit into opposite studs when connected. This would physically prevent the gears from separating even if the attachment faces resistance while completing a mission.
Next are multifunctional attachments. There are attachments that do more than one thing. For example, you could build one that could push a model and then flip the lever, all in one trip. Multifunctional attachments save time and space, but they need good design and testing. That's it. My sister Noelle will be presenting building instructions.
Okay, hi everyone. My name's Noelle. I'm Natalie's sister, and I competed in FLL like 2 years ago, but now I'm doing a different competition called WRO. But I think I'll be like your mentor for this year's season. Today I'll be talking about these different build instructions and like my opinion and my suggestions for them. So the first one, this one is the advanced driving base assembly. It's a robot that's great for kids who are learning how to use the motors and sensors and how to navigate through routes. And so for your FLL, I would suggest building a robot that fits your missions and then tailoring the robot to what you need. So you guys can start with this robot, like start to build it, and then you can like make changes to it if you need. Because I know that in my experience, it's really hard to just come up with a robot like on the spot. And so you guys can just use this and try to make changes to fit your missions. And then I know that you guys may already have a robot. So I would, if you guys do, I would just look at these parts and see if you guys can add some to make it better. And then the next one are these driving base models. These are really basic robot models for beginners, like really young kids. This first one is driving base 1, and it's the simplest out of the 3. So it's really just 2 drive motors and then a hub, and then a extra motor for like attachments and stuff. And this is just good for driving around for you guys to learn how to drive and turn and do all the other stuff. And then this one, driving base 3, is the next complicated one, and it's for you guys to learn how to use the color sensor. And color sensors, you guys might not use it because it's mainly used for line following and your map doesn't have any lines. So I don't think it's applicable, but you guys can have fun with it, play around with it.
Yeah, we do
And
have
then,
lines on the map. There is the black line, black and the white. There are a couple locations. They have that black and the white line.
yeah, there's a little bit, but
Mhm.
but it's not going to be really great because it's just a tiny little line. But you guys can play around, see if it works. And then Driving Base 2 introduces the distance sensor, which is used to like measure the distance between the sensor here and then an object. So for example, if you're like 5 inches away from a wall, you can like write code and then tell the robot to stop when it's 3 inches away from the wall. So the robot would use the distance sensor and then to detect how far it is away from the wall. And then there's also a force sensor right here. I don't know if you guys can see, but it's kind of like a touch sensor where it can do something when you press it. So for example, you can code the robot to stop when it hits an obstacle, or like when the sensor hits an obstacle, and then you can trigger some other actions with like a press. And then lastly, you can just put attachments on the robot and then learn how to move the attachments and power it. So these are just really basic models. And then the next one, this one's really, it's a marker. It's really simple. There's not much to it. So it's kind of just like a tool for your like signal for a robot. And so I personally have never used this marker before, but I've seen it like here where you see a robot driving around it. So it's kind of just for like practice. And then the next one, these are like examples of mission modules. So it's just extra mission practice that Lego provided. They're really similar to the actual missions that you guys may like need to solve, but they're obviously not the exact same. And I would say it's pretty good practice for the team to get familiar with these types of missions and are pretty good learning materials. This is like kind of a video showing how it works. Okay, yeah, so that was just that. And next, these are tools. These are some attachment like tools that you guys can play around with. I don't think these should be your actual attachments in the competition because they're really hard to put on and they may not fit every single mission. So I would tell you guys to play around with them, experiment with what you guys can do. And when I did the competition 2 years ago, we were not really experienced and we were all beginners. We actually did use, we took this attachment and we modified it a little bit, but it wasn't great because it didn't work for every single mission. We we changed it a bit and tried to make it more adaptable, but still wasn't like the best. It's good for learning, but I wouldn't use this as the exact same one for your missions. And then here's a video of our mission run. So you can see here, this was our attachment, and then this was our other one. Okay, so that was our mission, our robot. You can see that we only used like our attachments a couple of times, which or like our attachments that are already on the robot a couple of times, and so it wasn't really great. So I would suggest to use more attachments that you guys are going to use for every single mission, or at least most of them. And then next, I have a video of a competing team or one of our competitors the couple years ago. And they actually did really good. I think their run was great and they had good attachments. So this is like an example of a good video. Okay, so that was the video, and you can see how many attachments they used and how easy it was for them to take off and put a different one back on. So that's like an example of a really good robot build. So that's it for me.
Hey, I think everybody learned a little bit about our robotic build and also the attachment build from today's meeting. And I think we have the next meeting is on Saturday, correct? Saturday, same time. Let's see what's next time's topic. Who gonna present next time? Next week, next meeting is on Saturday, 7 to 8. It's Charles and Joshua. You're gonna present the deep dive training camp. Joshua, you there? Okay, if not there, I'm going to send you a message about that. It's gonna be your turn to discuss about the technical and deep dive, the training camp one. All right, that's for today's meeting, and hope everybody have a good one. And then see you back on Saturday. Yeah. All right, I call end of meeting. Bye.